pick out some good problems that I would like to talk about. So remember, the differences in the conic sections is you have four kinds. You have a circle, you have a parabola, you have an ellipse, and you have an hyperbola. Okay, and so a lot of times you have to just be able to recognize what kind of problem you're working with in order to actually do the graph of the conic. So it's really good to know the general shape, or the general equation. So circles are x minus h squared plus y minus k squared equals r squared. That's r for radius, okay? Where h and k is the center. So hk is the center. That one's not too bad. The parabola is y equals 1 over, some books use a C, some books use an A, some books use a P, and I can't remember. I think this one was a C, if I remember right. 1 over 4C parabola equations. And the circles are nice because there's only one. And the other parabola equation is x equals 1 over 4c times y negative. This parabola opens to the right if c is positive, and it goes to the left if c is negative. So this is the value of c, or the sign of c. And that's kind of the general shape of how those go. Because if what you're doing is just, well, hold on a minute, let me get this out of the way because I need room for two. So the ellipse equations are x minus h squared over a squared. And an ellipse, well, we'll get to that in a second if we have time. So that's the equation for an ellipse. An ellipse is going to look like, if it looks like this, so think about it. When the B is the major axis, it's below the Y part of the ellipse. If the bigger axis is parallel to the X axis, then the major axis is the X one, and A is bigger. Hyperbola, it's going to look very similar to what I just wrote. And the only reason I know these so easily is because I've worked with them a lot. Now, what's the only difference in the ellipse and the hyperbola? Only one difference. Be able to tell them apart. Is the ellipse is a sum and the hyperbola is a difference. Oh, you know what? I meant to have my video running. There you go. Did I have it? Did I get it started? I think I did. Hold on a second. I think I got it running. Okay. So the thing that's important to remember about the hyperbola shape. All right, let's see, do I have some more space? Can I go down a little bit? This hyperbola shape, because the x is first, it opens this way because the x is first. The hyperbola that opens the other way looks like this, y minus k squared over a squared minus x minus h squared over b squared equals 1. Still, this one is first, but it's the y. So this hyperbola opens on the y-axis. It opens up and down. So whichever of the, in hyperbola, on the y-axis. So A is bigger in ellipses. That gives you your major axis. And in hyperbolas, A is always first. A being major axis. So that is a lot of information in a very small amount of time that you need to be practicing this material that quickly. So sometimes you're asked just to look at an equation and tell what kind of conic section it is. For example, there's my daughter, plus 10x minus 18y plus 25 equals 0. Now this is not in vertex form. This is in standard form. This is in the format that I can't really graph this from this version, but I can do a lot with it that I know what two things. Any of the variables that are squared. Okay? Since they are both the same sign, then I know it is not a hyperbola. Since this number here and this number here are not the exact same integer, I know it's not a circle. So it's either an ellipse or parabola. Since both variables are squared, I know it's not a parabola. So this thing is an ellipse. I also, well, I won't even say that. So this is an ellipse. I was going to tell you which of the major axes was, but I don't even think you need to know that. All right, so here's the kind of the checklist to look at. If only one variable is squared, it's a parabola. If it's an x squared and it's a positive x squared, it opens up. If it's a negative x squared, it opens down. If it's a positive y squared, it opens this way. And if it's a negative y squared, it opens this way. Okay, so that's parabolas. Then you're going to check, okay, so if that's not the case, then that means you're going to have two variables that are squared. It's a circle. Okay, so that's pretty easy. If they are different signs, I don't know what I'm trying to write. Okay, so if they're the same sign, it's a circle. Oh, that looks like a negative. Let me fix that. If it's the same number, it's a hyperbola. It's the only one with the subtraction. And then the only other thing left is an ellipse. Okay, so that would mean the coefficient of the x squared and the y squared. So it's just it's kind of a process of elimination. If it's do is tell what kind. That's pretty easy to do. Now let's do one where we got to tell what kind it is, come up with the problem in the vertex form, and then kind of sketch a graph because that has a lot to it. What time is it going to be? Okay. Let's do one that, oh, there's so much good past my time. Well, let me do one of these. You have to remember, I want to instruct every single piece and part because I think it's so interesting. So you got 4x squared plus y squared minus 16x plus 15. Okay. The first thing you have to do is same. The signs are the same, so this thing is an ellipse. Okay, and you have to keep that in mind because once for the x terms. Oh, this one actually is nice because there's no y to the first. And I'm going to move the 15 over. Okay, so we have to complete the square, but the thing you have to remember in completing the square is this has to be a 1. So we're going to pull the 4 out. We're still leaving our place. We're not going to have to complete the square here, so that's kind of nice. We only have to, oh, not 0, 15. We only have to do it one time. If there was a y term in the problem, like a 12y, remember you have to find that number that goes here. So you take your middle term, 4, makes a perfect square trinomial, but be careful when there's a number out here, the one you're adding in there is actually what you're going to do is add over here 4 times 4. So you just all right, so this is 16, and negative 15 plus 16 just gets parabola yet, or an ellipse. Because we can't have this coefficient here. And typically what you do is divide by the number that's right here to make this be a 1, but it's already a 1. So what we have to do, I'm thinking, hold on a second. Oh, look what I did. I'm sorry. Nope, that's right. Hold on, let me double check. I'm thinking I wrote the problem down wrong. Hold on. 4x see, hold on. That was supposed to be a minus 16, but that's okay. We're going to leave it a plus 16. In an ellipse, and here's the dilemma I'm having in my mind. This needs to be a 1 for sure. We can't have a coefficient. Four half squared added. We add it here. We got to add it here. Not a good example if I can't come up with why and how we handle that. If we divide typically what happens is there's a number here and you divide everything by that number so that you have make this be a 1. This is already a 1. So I don't know. If we divide this by 4 and divide this by 4 and divide this by 4, I'm going to have to start over, I think. But that's going to bother me. Makes that a negative. And that makes this a negative over here. But that doesn't change anything. If you add 16, you gotta add 16. That was a plus 15. I know, I'm sorry. Okay, this is a little unusual of a problem. Sorry. I knew I could think of it. All right. What we have to do is make this 4 not be in the numerator. And we're going to do that by multiplying by 1/4 over 1/4. Because 1/4 over 1/4 is just 1. So for this term, what happens in this numerator is 1/4 times 4 equals 1. And then our denominator, here we go, we're back rocking and rolling, equals 1. And I knew that this had to be 1 because that's the format for ellipses. Okay, but so we're going to rewrite 1/4 as 1/2 squared. And we're going to rewrite 1 as 1 squared equals 1. And there it is. It just took me a second to process. I knew we could do it. You can multiply anything by 1. So all I did was to multiply this one term by 1. And you have to be careful. You have to be real careful. All right, now that we have this, we can talk about what's going on in the graph. What happens with the graph is first we want to find the center of the graph, the center of the ellipse. And the center of the ellipse is 2, 0 right there at 2, 0. And then what you're going to do is you're going to count left and right on the x. So I'm going to go left a half a unit right here. It's going to be a little skinny ellipse, and right a half a unit right here. And go down 1 unit, oops, here. And so there's my handy dandy little kind of and that's what that's going to look like. So graphing them, once you get it in the vertex form, is really easy. Now the cool thing is the relationship between ellipses and hyperbolas. Actually, let's just do that real quick. Hold on. Can I get this right here? And can I get that right there? Perfect. I'm going to copy that. I'm going to paste it onto an. All right, so here's our little picture, and here's our crazy looking graph. Let's say our equation was not a plus. Oops, didn't mean to do that. It was not a plus. Reach my graph down. There we go. Here's how it changes. This is kind of cool. Because the major axis in a hyperbola is first. Now think about cutting it in half and taking this half and shooting it out this way, and taking this half and shooting it out this way. And so that this part of the ellipse that I'm erasing out, I don't know, you can't see, like this. So here's our ellipse. We're going to cut it right in the middle, and we're going to shoot it out. If it went like this and the ellipse was up and down and it opened on the y-axis, it would shoot the ellipse up and down. So it's kind of cool how the ellipses and the hyperbolas are related, because if you can graph an ellipse, you can graph a hyperbola. You just got to shoot it away from the center instead of toward the center. So I just think that that is a really cool relationship of how that all works together. And I'm sorry it took me so long to get that denominator thing. I knew it was right there on the tip of my tongue. I was just weeding through my brain to get that information together for you. So that's kind of a very quick, a lot of information about hyperbolas and ellipses in a very short amount of time. Let me give you one more little something to think about. Let me find. Let me see. I want to do one where they give you parts of the problem. Let's do this one real quick, where they give you parts and pieces of the hyperbola. I'm kind of going to focus on ellipses and hyperbolas because I think I did some parabola work before. All right, so this is a hyperbola, and they're going to give you some pieces of information. One of the pieces of information we have for this particular problem is 2, 2 for the vertices. Ooh, I don't like that because that's going to be confusing. That doesn't help. Okay, let me pick a different one. Sorry. Because it's confusing of which two. Let's do this one. 10, 3 for the vertice, one of the vertices, and 6 your memory, you should know. It's 12, 3, and 8, 3. Okay, for hyperbolas. Now, the best thing to do, even though it doesn't say graph it, it says write the equation of it, is to graph it. Because by graphing, you get a very good view of what's happening, and that helps you. Let's call this 3. So 10, 3 is here, and that's a vertice. And, oh wait, no, let's call that 6, sorry. Call that 6. And we'll call 10 out here. This is 10, 3 right here. 12, 3 here, and 8, 8, 3. Hold on, did I look at that wrong? 10, 3, 6, 3. That can't be right. This is wrong. It should be 4, 4, 4, 4. That's a mistake in the book. That should be 4, 3. Okay. Where's my green pencil back? All right. So at 4, 3, we have another foci point. Okay. And this one is a foci point. Now, hyperbola's focus points are on the inside of the little branches that shoot out or shoot out this way. Okay. So that tells me a because the focus points are always on the inside of the parabola parts of the hyperbola. So what does that tell me and why is that important? That tells me that the x part of the hyperbola goes first. And I know it's a minus because it's a hyperbola. Oops, that may not be a minus. In those spots. Now remember, what goes here and here is the center of the hyperbola. Well, look at the picture. The center is going to go right there. Okay? So what's between? It's in this direction, so that puts that at 8. And then so the ordered pair right here is at 8, 3. I didn't have to memorize the formula. I didn't have to come up with that. I just looked at it. And I know that the 8 is the H and the 3 is the K. So the H goes with the X and the K goes with the Y. So that part's done. All I had to do was but we can do it by just looking at the picture of the graph. All right, so let me grab a different color here. All right, so now we've got to come up with what goes in the denominator. I know that this number is this distance from the center goes right here. So in this case, it's 2. So 2 squared. That's my A. Remember, in a hyperbola, that's your A. Now, here's the thing. To understand and know a little bit about hyperbolas, there's a lot that I've kind of glossed over. So the distance from the center to the vertex is A. Relationship, and here's the relationship. It's A squared plus B squared equals C squared. You've seen that before. Okay, but the distance of A is from the center to the vertice, and the center to the focus is the C. So we have so by looking at the graph, I can figure that out. I don't have to memorize anything. So I get 4 plus B squared equals 16. I'm going to subtract 4 to both sides. So B squared is 12. That tells me B is the squared if you actually wanted to be specifically perfectly correct, because it is B squared. Okay? So that is a lot of information in a very short amount of time. Now, let me tell you what the B is. The B is the distance from the center downward to make a little box. Create the asymptotes. See, it's so cool. It all just works together. It's so wonderful. I know. I can't help it. I'm kind of nerdy. So the distance from the center to the vertex is the A, and the distance from the center to, I guess it's like the I don't know. I'm not even going to any ellipse, it would be graphed in a very similar way, except the focus points would be on the inside instead of on the outside. And then instead of it shooting out, it would go together. So there you go. All right, a lot of information, and I know that I went a little bit longer than I normally do, which means I'm kind of late for my next session, but I can record a little bit later, and I think it'll be just fine. And it's just a lot. So if you're stuck on any of the stuff with conic sections, if you need help with any specific thing, nobody sent me any questions, so I'm just not exactly 100% sure what you need help with. Free to keep me posted of how it's going. Conic sections can sometimes be tricky, so just hang in there, keep trying, don't give up, and let me know when you need some help. All right, let me get the recording.